So I already sent an email about the fact that we will have a test on next Thursday, and then the TAs are setting the test. Some of the TAs are very happy about the fact that they came up with really nice questions. So I don't know whether it's going to be all that easy. We might be a fan or something and put it here. But in general, as I said, we will try to make sure that questions are easy enough for you. And as I said, the material would be essentially until last class. So the stuff on today onwards is not part of the test. Okay. And then basically we'll have higher emphasis on the stuff that wasn't part of the midterm then. Okay. But midterm one stuff is fair game in the sense that people who may have done badly in some questions then, if they can do well in an easier version of those questions, that will be other thing. So I would suggest that my expectation is that if you spend so much time doing the real test as well as the at-home test, you should have to really study the other parts, hopefully, and you can study the ones that were done afterwards. And then we'll get all the homework solutions before the exam. In fact, the ones that are already completed, we will just basically give it by hopefully this weekend, not later than this weekend at any rate. And the last one, on the planning one, we will make sure that it's there on Tuesday. That's why for the planning one, the planning logic one, there is no extension available, okay? Because that's the only way I can give the answers. Okay. Yes?
Since the TAs are writing the exam, should we expect a similar format to the first midterm?
No, it's just, well, if first homework, first midterm was easy breezy, then yes. If not, then not. Okay. So we are going for easy breezy. We don't know how to set those exams, but we're going to figure out. Maybe we'll ask you to write your name without spelling errors or something. Okay. Yeah, no, I think it will be, it should be, my hope is that they'll be like some of the easier homework questions type. That's what we will try to do. And there won't be any true and false questions. No true false with justification questions. They will come back. They will come back for the final. Okay, any questions? So I mentioned this that, so I understand that you have to kind of study for this, obviously, and that might take away some time from your final project, project 4. So depending on how things are going, I will just extend, I'll consider extending the deadline for project 4. My expectation is that if the project 4 gets done on the day it's supposed to get done, for most of you, then we can try to have a non-coding Bayes network exercise. It doesn't involve any coding. It's like actually using a Bayes network tool. If we do that, if on the other hand, people, I ask you closer to the deadline, and if people are having trouble, we just extend the project for deadline so that everybody can have. At least as far as this class is concerned, you are not going to lose time. The rest of your life, the report doesn't exist. Okay. Okay. Any other questions? Any questions at all? Okay. So we are almost in the last topic, which is of course also a very exciting topic. Probabilistic propositional logic and Bayes networks. And in fact, depending on the time, we not only will talk about specifying. So this one combines, in fact, everything that the logical piece that we will take. For example, we talked about how to write the knowledge you know and how to do inference with it. Similarly, we will here too talk about how to write the probabilistic knowledge you know and how to do inference with it. Okay, but then something that we didn't do here, but we'll do for probabilistic reasoning, depending on the time, hopefully, is to also talk about how you could have learned knowledge in this format. Okay, you could have done this for logic too. For example, instead of learning neural networks, you could have learned logical sentences from examples. Okay, and we will actually talk about probabilistic logical sentences from examples, not probabilistic logical sentences, but probabilistic logical networks, which is Bayes nets. So we'll talk about how Bayes nets can be learned. Okay, and that actually would also put, in fact, Bayesian learning is really the basis of machine learning. I mentioned this multiple times during the learning time that, for example, something like dropout is essentially a poor man's or poor woman's way of doing Bayesian learning. Bayesian learning is stochastic, so by the way, which reminds me, tomorrow actually I said there's one talk already which I mentioned by Ronnie Cardon, and that's at 10 o'clock. And then actually there are like 4 talks tomorrow, I don't know what happened. But there's another talk that's also potentially interesting, not as, both of these are going to be state of the art, so you may or may not make too much sense of it, but they're connected to the topics we're talking about. The second talk we're talking that as a follow talk is on Bayesian optimization. And in essence, Bayesian optimization is Bayesian learning. So in general, as I remember the thing that I mentioned about Bayesian learning, when a Bayesian goes to a fork, they'll just say we'll take it. That's the way to remember it. We'll never make up our mind as to this side versus that side. Let's have both of them. Okay? And because of which they would not have any overfitting problems. All the other stuff that we talked about for machine learning algorithms which have problems with overfitting, etc., they don't exist for Bayesian learning. Except Bayesian learning can't be done. Okay? And so it's kind of, we will also talk a little about that. Okay, so that's where Bayesian networks, inference, and that's what, this is pretty much the main last major topic that we'll get to cover on these things. Okay, so, okay. Okay, good. Okay, so quickly, solving problems in propositional logic. We talked about how to write stuff that we know about the world in propositional logic. For now, imagine that you know something about the world and you're writing it now. Okay, we're still in the inference way, where we have knowledge about the world and we want to tell it to our system, and then it will do some reasoning with it. So you can basically, in the case of propositional logic, you basically write down what you know as propositional formulas, then the essay SAT and theorem proving procedures will tell you useful things about the knowledge you have written. Okay? There are 3 kinds of things that you get to do in propositional logic, in case you haven't realized it, we have talked about it before. One is, you might ask before even starting, is my knowledge base consistent? That means, remember that it's very important to remember knowledge is constrained. It's kind of strange. People say the truth will set you free, knowledge is liberation. No, knowledge is constrained. People who have empty minds think everything is possible. Earth can be revolving around sun, sun can be revolving around earth, both of them are hanging around in some restaurant, everything is possible. Because you have knowledge, many, many things are not possible. Knowledge constrains your world. You see what I'm saying? And so, now the question of course is, if it constrains it so much that there is no world, that's a problem. Right? And so, first question you want to ask is the knowledge that you have consistent? Are there any worlds which are consistent with what you know? In which case, one of them is the real world you are in. Right? In the context of propositional logic, the worlds are those rows in the tables. Each row is a world. And so you want to know, are there any rows which evaluate, in which all the knowledge that you have evaluates to be true? So every propositional formula will be true. Right? And if there is no such world, then your knowledge itself is inconsistent. That means there's actually, you have some, there's no way all of these things can be true in the world you're in. Okay? The second is, given a new sentence S, is it entailed by my knowledge? Can I write this down? I have some knowledge, and you want to know, is S true? Okay, I want to be able to answer it. And so if I can prove that my knowledge base entails S, then I get to write S into the knowledge base. The point, of course, is in some sense, knowing what you know, S was already true. Okay, so it's very important to understand that when S is entailed, according to propositional logic, you are not learning new knowledge. Your knowledge is the same. Think about the following question. Suppose I have a knowledge base KB with 15 axioms or something. Okay? And it is holding true in 3 words, only 3 words, that means the 3 rows of the truth table. And somehow I found that a fact F is entailed by this knowledge base using our techniques that we talked about, either truth table based or model theory based. You understand that? Now I'm going to add F to KB. What's the number of words KB and F is true in? 3. You guys understand this? It's extremely useful. If on the other hand, F doesn't hold in the knowledge base, I mean if F is not entailed, you add F to the knowledge base, the number of words is going to be less than 3. Could be 0, could be 2, could be 1, but less than 3. That's how additional knowledge constrains. You see what I'm saying? Think of knowledge as constraint. Okay? The more you know, the fewer things you realize are actually possible. Okay? So anything entailed essentially was already true in the words that your knowledge base is true in. You just didn't realize it. You see what I'm saying? In fact, did I tell you that two super intelligent robots playing the chess joke? Yeah, what happens there? Essentially, the first robot takes some amount of time and makes the first move, and the second robot takes some amount of time and says, okay, you win. Right? Why? Because essentially we have to go through the moves to realize whether you will win or lose in a particular direction. Whereas if you can essentially do full entailment, given a particular board position, you can actually see if there is a way of winning from here or not. And if there is no way of winning, then you lost. Do you see what I'm saying? So that's what basically, so you may have learned what you should have known indirectly, but that is deductive learning. That means this additional knowledge is the deductive closure of the knowledge that you already have. Inductive means if you add an inductively learned fact to your knowledge base, then the number of words you are consistent with reduces. It's a very, very useful thing to understand. Okay? So this is the other thing we do. The third thing, of course, is the sentence as consistent, possibly true with my knowledge base? Is it possibly true with my knowledge base? So somebody wants to tell you a fact about the world. You have some prior beliefs. You can't, from those beliefs, you can't prove this new sentence to be true or false. The question you're asking yourself is it possible for me to believe this, put it into my knowledge base? Or if I do, then will it be inconsistent with some other things that I know of before? Do you understand what I'm saying? By the way, in a sociological sense, this is actually an extremely important thing. It leads to what's called confirmation bias. Filter bubbles. How many of you have heard of filter bubbles? How many of you have heard of filter bubbles? Okay. So nobody reads news anymore, right? People read what they basically already almost believe in. You see what I'm saying? If you are like a raging left-wing lunatic, you'll only read left-wing stuff. If you are a raging right-wing lunatic, you'll only read the right-wing stuff. Because those things are consistent with what you know. You understand what I'm saying? So if you find out, for example, according to this news article, that Hillary Clinton has grown 2 horns and is going around killing children, right? Depending on whether or not it's consistent with your knowledge, you're likely to agree, yeah, that's not possible. If on the other hand, if you have different beliefs, which if you believe this, you have to remove some of the previous beliefs, you're not even going to admit this. You can, by the way, substitute Hillary Clinton hands to Trump and whatever the heck you want. Okay, and I'm not basically trying to make any political statement here, but that all of us have actual knowledge, and we try to decide to believe or not believe something based on whether it is consistent with the knowledge that we have. And this confirmation bias, you almost want to believe this stuff, which is why when the news article tells you, yeah, that's great. Why do I want to learn some other stuff that, okay. So that's about the third thing. If S is consistent, if S is consistent, if not, S is not entailed, right? That means if you basically already given what you know, if you already can entail not S, then you can't believe S. If you must believe S, then you have to remove something else that you put in your knowledge base before. Do you see what I'm saying? And that's hard for people. That's why they just basically look for consistency. Yes?
For the first story, for the knowledge to be consistent, how is it required for it to only satisfy one world, not all worlds?
No, not all worlds. All worlds, of course. If anything satisfies all worlds, you have zero knowledge. Do you understand what I'm saying? In general, again, knowledge means constraint. If the universe, let us say, unbeknownst to us, has 2 power 357,000 configurations. Okay? And if your knowledge allows you to be in all of those configurations, then you don't have any knowledge. Okay? So, at least one basically is important because your knowledge actually doesn't make the universe go away. Okay? Again, this stuff is expected to be understood by people, but I think most people don't understand. Many of you think you know logic, and some of you probably didn't realize these connections. That's why I want to bring this up, specifically. Okay, so all this is well and good. So we have everything going. We can actually do this stuff. So the question, of course, is: are there things where this kind of propositional logic may not be the way you know about the world? In particular, you can see where I'm going. You want to talk about uncertainty. But I don't want to just jump into uncertainty. You kind of know me. I'll basically drag you slowly, bit by bit, into why you need uncertainty. Why you need something is way more important than how do I plug and check. Although you don't feel like that when your grade doesn't tell you understood something, but it's actually you need to understand why do you need probabilistic logic given this is there. And in particular, many of you probably have heard of things like fuzzy logic. Why not fuzzy logic? And some of you may have heard of, or if not, you'll be hearing today, of variations of logic called non-monotonic logic. Why not that? And so we will slowly go up, make our way into this, and then basically end up in probabilistic reasoning. Okay, so let's start with this example. This is from our attendance score. Okay, so a little story I have. Pearl lives in Los Angeles. It's a high crime area. Pearl installed a burglar alarm. He asked his neighbors, John and Mary, to call him if they hear the alarm. This way he can come home if there's a burglary. I don't know why you want to go home if there's a burglary. They'll actually kill you at that time. But Pearl wants to go. Los Angeles is also earthquake prone, in case you haven't realized this. Alarms go off whether burglary is occurring or if there is an earthquake. This is your knowledge. Okay? So you write this in this format. This is my propositional logic version of this knowledge. Burglary implies alarm. Earthquake implies alarm. Alarm implies John calls. Alarm implies Mary calls. The stuff in red, I just say those are the propositional symbols so that I don't have to write a big thing. Okay? So B means burglary, A means alarm, E means earthquake, and so on. Okay, so this is the knowledge. You wrote this down now. You already have. Now I can use this to answer interesting questions such as, if there is a burglary, will Mary call? Can I answer this question? If there is a burglary, will Mary call? That means I should add burglary to the knowledge base and see if I can entail Mary. If I can entail Mary, then Mary will call. In this particular case, that's true because burglary implies alarm will get you alarm, and alarm implies Mary calls will get you Mary calls. You can do this in the hard way by doing actual resolution theorem proving, or even harder way by writing an entire truth table, or just the easy way, which is I just showed you the chaining that happened in this case. But you realize that this is the theorem that is proved. That's actually proved. Okay? And then similarly I can ask, if Mary didn't call, is it possible that burglary occurred? If Mary did not call, is it possible that burglary occurred? Okay? So the question then would be, I want to check if knowledge base and not Mary entails not burglary. So all I'm saying is any question you might ask, these kinds of questions, if you have your theorem provers, you can call them to answer these questions. Okay? Now, this is all well and good, but you already start questioning the assumptions being made here. Los Angeles is a real world city. Okay? So there are a whole bunch of things that I'm assuming that are not actually true. Pearl lives in a real world, not a fictional world, where burglars can sometimes disable alarms. I mean, all the Hollywood movies, the first thing burglar does is cut the alarm. Some earthquakes may be too slight to cause an alarm. Even in Los Angeles, which is not exactly Phoenix, burglaries are more likely than earthquakes. John and Mary both have their own lives and may not always call when the alarm goes off. Between John and Mary, John is more of a slacker than Mary. This always is the case. Johns are always slackers. And John and Mary may call even without alarm going off. You understand what I'm saying? In the old days, by the way, when telegrams were invented, how many of you know telegrams? Right? Telegram was what code was used to send a telegram? Morse code. What were telegrams being used for? Mostly bad news. Somebody died, you send a telegram. So in fact, in my language, there are all these beautiful stories where the telegram comes, and typically this telegram, unfortunately, will be in English, and I speak Telugu, so all those people there used to speak Telugu. Nobody knows what is in the telegram, so they might as well start crying, because somebody died. You see what I'm saying? Right? Telegram means somebody must have died. Okay? Similarly, if Pearl thinks the moment John or Mary calls, he'll say, I don't want to take the call, must have been a burglary, let me just run. That would be bad. At least maybe they just called to say hello. Right? Just like telegram can be coming saying you just won the Publishers Clearinghouse lottery or one of those things, in which case it's good news. Okay. So this is all real world, right? So the question then is, in this world, first of all, how do I write the knowledge I have here in this? That's the first question. That's what we'll be asking. This simple knowledge is no longer being, this stuff is not captured by this simple knowledge. You realize that? Right? Because you're acting as if burglary always implies alarm. Okay, by the way, one thing just before I go forward, implies does not equal to causes. Sometimes by mistake I'll say cause, and you also might say cause, but implies doesn't mean causes. Logical implication is not causation. Do you see what I'm saying? Logical implication is not causation. But similarly, in fact, causality we would not ever get to, in many of these cases. So you may very well know that something is causal, and you wrote the implication there. But just the implication doesn't mean causal. It's actually causal. Okay, keep that in mind. Okay, so here, of course, we wrote stuff in sort of our causal direction. We think burglaries cause alarms. Alarms don't cause burglaries. So we wrote it that way. Let's think about that. Okay, so given that anyway, it's clear that burglary doesn't always imply alarm because there are all these additional things that are going on. And people don't always call, and people might call even when there is no burglary. All this crazy stuff is going on. So the question then is, and then, in addition to writing this, how do we, which are the other things? How do we write this? You need some language to write this in. Propositional logic is not enough. Okay? The second is, if I were to write it in, the kinds of questions we normally ask about our knowledge in real world are more than just these two kinds of questions. In particular, for example, the following question. Use your common sense, use your reason. John already called. If Mary also calls, is it more likely that burglary occurred? What do you think? No, if John already called, and if Mary also called, would you believe more that the burglary occurred or less or nothing at all? More. Most of you will believe more. Like if somebody comes running and says there's fire, you'll wait if only one guy came. One more person comes running and says fire. Two people, maybe let's start putting stuff in the bag. Right? Right. So, in some sense, logically, one person coming, fire, if in fact, when somebody said fire, there really is fire, you should have run after the first guy coming. But you assume that people have noisy observations. People basically might be, delusional. People may have had one too many drugs. And so all sorts of these things, and so you want to see, let's just wait for some more people. Right? Logic can't capture that. Our logical knowledge can't capture that. Okay? Now, you also hear on TV that there's an earthquake. So notice that in the beginning, either burglary or earthquake would have happened because alarm goes off, people come. That's all you know. Now you see on the TV that there's an earthquake. In fact, you probably are finding yourself in a movie. The question then is, do you think that burglary is more or less believable? You don't need 15 causes for one guy to die. It's not stopping you. In fact, people may well have been shot and hit themselves on the head as well as drunk themselves to death. All three on the same day. But you don't need it. Most of the worlds, typically that's not the case. And in general, this is plausible reasoning. We use this all the time. This is called explaining away. Politicians do it all the time. Okay? Here's some other explanation. So you don't need to be a bad guy because some other way this happened. Now logically, well, the fact that it could be B is true because of A doesn't mean B is true, B is not true because of C. But probabilistically, if B can be true because either of C or of B, and you know C is true, okay, so in the sense that if I basically think something like this, B can be true either because of A or because of C, and you already know A is true, you think C is less likely to be true. It's a strange thing we do. This is called explaining away. Logic doesn't do this. You need to be able to capture this, because this is how we actually reason about the world. See what I'm saying? So two problems we noticed is one, of course, we didn't get a language to write this. The other is we need to support these kinds of plausible inferences. This is the way we tend to look at the world, right? Okay. How do we handle real world? First, how do we write it? What is the language you write it in? The first idea that I will say is omniscient and eager way. Right, the problem you would say about the previous thing is, you said burglary implies alarm. Burglary itself doesn't imply alarm, but burglary and something else 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 implies alarm. Just write all of those conditions down. You see what I'm saying? Okay? And similarly, alarm going off, John calls is what you wrote. What you really have to say is, alarm going off, and John is awake, and John is not busy listening to songs, and John is not drunk, and John is something else, and John is something else, and John is something else, then John will come. You have to write all possible things that are needed for this rule to fire. This is called the qualification problem. You see what I'm saying? If it is a made-up world, you should be able to write down the exact number of exception cases that all have to be written down. But in a real world, it becomes hard. Okay? So as I said, model everything is the first idea. If you model everything, the logic that you know till now, the propositional logic will work without any problem. But modeling everything basically is like this. A and C1 and C2 and C3 and C4 and Cn. All of these are propositions, are subliterals. Implies J. And you need to figure out all these things. Now, if you think that the world only contains those 5 variables, then of course it's easy enough. But it's real world. All sorts of additional variables exist. And you need to think of how those things can change whether or not John is going to be come. Okay? This is called the qualification problem. And one of the interesting things is all the exceptions might themselves have correlations. Exceptions might have exceptions. You have to capture those too. Okay? Now here is my question. Imagine you're going to write the rule, a rule saying, if the following things hold, I will be able to start my car. Tell me a rule. If I have the keys, I can start my car. Is that really always right? No. What else? Gas, key. What else? Battery. What else? Tires. What else? Ignition. What else? Spark plug. What else? Unless you saw my slides, it's not of gas. After all the things you say, I will say, sorry guys, you did not consider the possibility of a potato being in the tailpipe. Of course, right? If you put a huge big potato in the tailpipe, you start the car, it will sputter and stop. It's one of the properties of potatoes. But see what I'm saying? Right? So, that's how you're supposed to actually. So now I basically told you that you could qualify all the conditions needed for you to start the car. Okay? By the way, McCarthy gave this name. John McCarthy, the same guy who I said also invented Lisp and also did a lot of work in logic. Basically, he talked about potato in the tailpipe problem, which is another colorful problem in addition to the bomb in the toilet. So you should talk to, in mixed companies, especially like in Thanksgiving, when the conversation is flagging, you should bring up these problems. And say, Mom, I'm really getting real world knowledge. Okay, so bomb in the toilet was a different problem, but potato in the tailpipe is today's problem. You didn't think about it, so you didn't write it. So you would have written all the other things and you would have made sure all of them are holding and you basically start the car doesn't start. What you do? It will be very bad. Because they'll say logically the car should have started. Right? So logically you should be moving, but you should, you're in big trouble. Okay? So now the question of course is, you might say, oh, that's okay. What I will do is I will write this too. And next time onwards, when I'm starting the car, everybody will stand around my car to look at me because I look like the stupidest fool in the world because I just don't start the car. I first go look under the hood. Then I look